Welcome to Civil Engineering Masters. In this lecture, we will see methods of discretizations. Okay, discretization here it refers to the how we are going to uh, divide or discretize a structure with respect to their masses. Okay, that one we will see in the methods of discretization. Okay, there are three methods of discretizations are available. First one is lumped mass procedure. Second one is generalized displacements method. And third one is the finite element concept. By using these three methods, we used to discretize a structural mass. Okay. In lumped mass, in those, first one is the lumped mass model. This one also called as the discrete model. Okay. What we used to do, the mass of the system is assuming to be concentrated, okay, concentrated, localized or lumped. The mass may be localized or lumped all together as one mass or localized at different locations, okay, in various discrete points around the system. Okay, the mass will be mass is assumed to be concentrated in various discrete points around the system. We used to call this type of systems we used to call as the lumped mass system. And this lumped mass system we can analyze by using the single degree of freedom system or multi degree of freedom system. Okay, in single degree of freedom system, the entire mass m of the structure is localized at a single point. Okay, the mass of the structure has been taken as a single mass. The mass of the every slab and column or beams has to be taken as a single mass system. Those type of methods we used to call as the localized method. And the entire mass m of the structure is localized at a single point. At particular point we used to localize, we used to keep that particular point at certain height. Okay, and there for single mass we can see only 1 degree of freedom. Okay, that 1 degree of freedom we used to call as the single degree of freedom system. And we can define that mass into multi-degree of freedom system also. We can discrete the total mass into different parts also, and every parts we used to assign with the one mass component m1, m2, m3 like that. If you see here in this figure, you can take this whole mass, the total weight of this structure, total mass of this structure as a single mass. And here we used to consider some height of the building. And during the earthquake, when we apply excitations, when we apply the force over this particular single degree of freedom system, if you are here, we used to assume total mass a lump mass, okay, localized mass at single point we have concentrated this load. When earthquake comes or any dynamic force if you apply, the displacement of the structure will be happens like this. Okay, the displacement of the structure happens like this. X of t is nothing but here displacement of the mass due to the height and earthquake force. There will be displacement of the mass, and that mass has been displaced with the amount of x of t. Okay, you can see here. This is the lumped mass system with single mass m1 as a single degree of freedom system. Another one, more than 1 degree of freedom system, one mass is there in that structure. Those type of structures we used to call as the multi degree of freedom system. In multi degree of freedom system we used to see more than one mass. Okay, and each mass will have one displacement. Here this structure, same structure has been divided into different three parts of the mass. Okay, first part of the body we have considered as m1, second part of the body, second mass of the body we have considered as m2, third mass of the body we have considered as m3. These are the three masses, and three masses will have three type of displacement. You can see here x1 of t. When earthquake force comes, during that earthquake force, this mass will try to move in opposite direction. When it moves in opposite direction, then each mass will be displaced from its original location at a distance of x1 of t to the mass m1, x2 of t to the mass m2, and x3 of t at mass m3. These are the displacement components of the mass, lumped mass system with different mass system, discretization of the mass. Okay, these two systems, and this system we used to call as the multi-degree of freedom system. Okay, this is regarding the lumped mass system. And another one, these all are the examples. If you want to see, you can see there. Here this beam has been considered as single mass and M has been applied here, and this beam has been applied as single mass and mass has been subjected here, and both the masses will be displaced like this: x1 of t for the mass m1 and x2 of t at mass 2 when we apply the dynamic force. Similarly, in the beam also we can divide into three parts, and each part is having the mass m1, m2, m3 and their displacement in vertical direction. We can see for mass 1 y1 of t, for mass 2 y2 of t, and mass 3 y3 of t. These three are the displacement components in vertical direction. Okay, sometimes when we used to take structures like this particular mass will be rotated. It will be subjected to some eccentrical distance from the bottom, vertical direction as well as horizontal direction. Because of the earthquake force, this will displace in horizontal direction and it also displace in vertical direction, and this mass also try to rotate theta of t. Okay, these are the force displacement components which are coming from this particular mass during the earthquake or any dynamic force. Okay, next one. Second method is generalized displacements method. Okay, in this method, mass is considered uniformly distributed throughout the system. The mass will be distributed as a single mass, uniformly distributed. The mass will be same, thus irrespective of the size. The size, the mass of this system, mass of this particular point, mass of this particular point, every system has been classified as a uniform mass. We used to take this one as uniform mass. Then for uniform mass we used to get rectangular type of shape instead of this trapezoidal, and that rectangular type of shape will be displaced at a distance of x of y comma t in y direction as well as x direction, sorry, displacement in y direction with respect to time variation. Okay, that one we can see uniformly distributed load. Okay, in reality structures have an infinite number of degree of freedom system. If you want to consider any system, there are infinite number of displacement systems we can consider at this particular slope of the structure. Okay, that's why they have mentioned here. In reality structures have an infinity number of degree of freedom system. Using the continuous model, a better accuracy of the resultant can be achieved in a dynamic analysis, that by lumped mass model. Okay, we can get better result we can get from the generalized displacement method or continuous mass method. Another one is finite element method. In this particular method, this one is the combination of both the methods, combination of discrete and continuous model. Okay, in first method, in lumped mass system we used to discretize the structure. In continuous system we used to distribute continuous mass, equal masses over the structure. Okay, this combination of these two we used to call as the finite element method. The structure is divided into different elements which are concentrated at discrete points called as the nodes. We can see here different points, each are one element, and these are the nodes. Okay, and each node will be concentrated at their corners, and each node will have some displacement. Okay, for every node there will be one displacement. Okay, number of displacements are equal to number of nodes in this structure. The nodes are allowed to displace in a prescribed manner to represent the motion of the structure. To indicate the motion of the structure, they used to displace in prescribed manner. In prescribed manner they used to display. The sum of the displacements in translational and rotational represents the total number of degree of freedom systems. The total number of degree of freedom systems described here, they may be translational, vertical or horizontal or rotational. Okay. The mass of the system is concentrated within each element. The mass of the system will be concentrated at each of the element. If you take every element is having their own mass. Okay, this is regarding the finite element model. With this I am stopping here. Different type of methods of discretizations. With this I am stopping this lecture.